Oh, shit. Come on, little dude. There you go. Okay. So let's look at the rest of this. So last time we talked about reference angles. Does anyone remember what the hell a reference angle is? You guys. Anybody else remember what a reference angle is? Yeah. What is it? And you're like, come on, man. I just want to let you know I can remember it. Oh, okay. I won't pick on it.
It's the angle when you know, like say 135 and angle 55 are equal because you subtract from 180. Okay.
Yeah, so it's, when I say reference angle, it's in reference to the x-axis, right?
Yeah.
So, could you all right now, whatever paper you got out for notes, because everybody's got that, could you just draw a circle, unit circle kind of thing, and indicate 240 degrees. Draw where it would be. 240 degrees.
Roughly where it would be.
Yep. So I mean to draw this guy. Right? You can make it even better than that, hopefully. And
Not
then,
much, but yeah.
huh?
Not much, but yeah.
Where would 240 degrees be? Third quadrant, I love it. So here's the way to say this. Either you say, how much past the x-axis did I just rotate? Or you say, how much before the x-axis did I stop? So did I just rotate past the x-axis? How much past the x-axis? 60 degrees, yes. Because what's the x-axis in the back there? What angle is this? 180. You guys all with me? That's all they are. That's all they are. So what the shit good is this? Is a good next question, right? So can you imagine I can make a triangle here? Yes, and then I can ask questions like what's the sine of 200? What's the sine of 240? And what's the cosine of 240? Right? You guys all with me? So the reason we only have to memorize first quadrant stuff is because this triangle is the same as that triangle. And it would have an angle of 60, yes? All right, that's what reference angles do. If I figure out the reference angle, I figure out what it would be if it was in the first quadrant. And I've got those memorized. So sine of 240 is related to sine of 60. You guys all with me? Because they both come from the same triangle. Except what's true about sine down here? Negative. So that's exactly how you would do this. This is beautiful work to show me. Even this disgusting off-centered circle, poor little dude, it's not your fault. This would be great work to show me on a problem. You guys all with me? And of course, the last part, this is the more recent stuff. Who remembers what sine of 60 is? Rad 3 over 2. I love it. If you're still having trouble remembering, sine likes y. 60 is close to y, so it's going to be the bigger option. Not 1/2. It's going to be rad 3 over 2. Stop for a minute. So let's look at what I got here. So I kind of gave you a little help because we haven't talked about radians yet, but that would be the same as 330. Where's 330 at? Yeah, I don't have to draw the circle really. How much before the x-axis did I just stop? 30 degrees. So that's the reference angle. You guys don't understand? Reference angle it's barely a thing to worry about. Right? Either I went past the x-axis or I stopped short of the x-axis. Just how much is that? That's the reference angle. This triangle would be the same as this triangle. Well, if I drew it better. Right? Get out of there. So this question, sine of 330, is related to sine of 30. And again, is it going to be positive or negative? Negative, because sine likes y, and in the fourth quadrant, y is negative. Are you guys all with me? Is everybody really with me?
Sorry. Could you repeat that again?
Which part? The last thing I said?
Yeah.
Fourth quadrant, is the y positive or negative?
Negative.
There you go. Sine likes y, sine's negative. See, SOHCAHTOA won't do that for you, will it? Sorry, I keep shitting on SOHCAHTOA because it should be shadow. Yes.
And then the other example, the sine of 60.
Oh, the one on the back? This guy?
Yeah, the 60 was in the first quadrant, so
Totally.
why did that turn negative?
No, 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 no. 240 is the question, correct? That is the question. I cannot change the question. I need you to understand this. And that is where sine is negative, correct? But to make it easier to memorize, we only memorize first quadrant values. So I know the answer is going to be negative because I am in the fourth quadrant, right? This triangle is the exact same as this triangle. They are the same triangle. So the number will be the same. The SIGN, positive, negative, might be different. Does that make? So that's why we only have to memorize first quadrant, thank the gods. We just put the plus or minus in based on what cosine, so what they are in that quadrant. Okay. How you guys doing? I like it. All right. Some of you guys are giving me a thumbs up while your face is doing this. All right, sorry. That was the greatest. All right. Sorry. What's the first thing I should do to this guy?
Subtract the rotation.
Yeah, kind of like, actually I'm going to add a rotation, right? Because somebody took the sucker back too far. So if I add 360, I'm going to end up in the same place. So I'm not changing the problem, correct? I need you to really understand that. I'm not changing the problem. I'm just going, let me add so I can see really where I am, right? So if I add 360, where do I end up? Can you guys take a moment and just draw negative 120? Don't say anything. Just where is negative 120? If you're not sure, I can't remember if we've directly talked about this, but hopefully this should make sense. Angle, I normally go counterclockwise. So negative angle, I'm just going to go clockwise. I'm just going to rotate backwards. So I end up in which quadrant? Good. So if I go back 120, how short of the x-axis did I just end up? 60. So my picture's not really drawn to scale, but it doesn't matter. So my reference angle is 60. Do you guys see that? Finding a reference angle cannot be difficult. Cannot. Yes?
So, how is it 60 if 120 is 40 degrees away from 180?
Think about it. 180 minus 120.
40 degrees.
What's 120 plus 40?
Okay.
So 180 minus 120 is 160. I'm sorry, 60, right?
Okay.
Yeah, okay. So, all right. So I know the answer is related to cosine of 60. The only thing I have to put on top of that is, considering where I am, is it going to be positive or negative?
Negative.
Negative. Yes?
Should it be cosine negative 60? Does that matter?
No. So reference angles are always positive. They are a distance away from the x-axis in an angle sense, right? They're never going to be negative. Reference angles always live in the first quadrant. Because then it matches with what we have memorized. The actual angle in the problem tells me what quadrant, which tells me is it going to be positive or negative. Is that cool? So you got kind of two things going on, which is great. Because I don't know what the hell. I don't want to memorize cosine of negative 120. I don't want to memorize all those. That's crazy. What's cosine of 60?
Negative right there.
1/2.
1/2. Cosine likes x.
Oh,
60 is far away from the x-axis. It's closer to the y-axis. Cosine's going to be scared. Oh, shit. So it's going to be the smaller one. It's going to be 1/2. So it'll be negative 1/2. I despise straight up memorizing shit. That's why I said, I came up with this idea of if I'm closer to the y-axis, cosine's smaller, sine's bigger. Because of where they like it. Cosine loves to be in the x-axis. It's 1, it's happy, it's fully out. It's like, yeah. As to go away from the x-axis, oh shit. And of course, when I'm at the y-axis, I'm like totally, oh shit. Okay, 0 at the y. Are you guys kind of? Okay. It's a weird math turtle. Okay. Turtle. So this would be negative 1/2. Now, part C has a couple things happening. Would you agree? For one thing is the angle, and we can do exactly what we just did, but on top of that, it's got a cosecant. And it's an option. You can memorize all the cosecant shit. I would not. Because how could I immediately... That's just water. I don't know. How could I immediately rewrite this in terms of sine?
1 divided by sine.
You guys all with me? You guys with me? Whenever I'm asking a cosecant, you can immediately rewrite it as 1 over sine of whatever angle. Because that's the relationship, right? Okay. Now, got no room for anything here. Negative 135.
Quadrant 3.
I am really all about quadrant 3 today. I have no idea why. So negative 135. How short of 180 did I just stop?
45.
45. And again, in this quadrant, sine is going to be negative. So I get this is equal to negative sine 45 degrees. All right, let me stop. It's kind of nice. And again, oh, maybe not. So here's the problem. First thing I did was write it in terms of a trig function I had memorized, right? It's the first thing I did. Then I did exactly what we were doing earlier. Just where's 135 go? It goes here, which is 45 short of the x-axis. That's my reference angle. And in this quadrant, sine is going to be negative, right? Do you guys see that?
Yes.
So the trade-off of not memorizing stuff is just remembering the parts, right? Just do one thing at a time. What is sine 45?
Rad 2.
Rad 2 over 2. All right, now here's computational stuff we are going to get all the damn time, the entire semester. How do I do that?
Rationalize?
Not yet.
2 over
Yeah. 1 divided by something is just flip it. Right? If I take 3 and I do 1 divided by that, isn't that just the reciprocal of 3? Right? What's the reciprocal of 3? 1 over 3. So 1 over something just flips it. So 1 over this just flips it. Now I rationalize. So I get negative 2 rad 2 over 2, and of course, what happens there? 2's cancel, so just get negative rad 2. Whew! So the first part of that problem was trig. And the last part was just simplification, like elementary algebra, which leaks out of our heads quick. Yes?
Do we need to show that work? Like, if we know already the hypotenuse is always rad 2, so that's why you just...
Yeah. So for me, what I would do is, I remember that rad 2 over 2 came from 1 over rad 2. So then I flip that and get rad 2, right? But I'm trying to do it based on what most likely most of you have things memorized as. Yeah. So there's shortcuts to everything. Yeah. Okay. Some of you guys look like you want to hurt me. I'll be all right. Is everybody okay with that? Any questions so far? As I look for some paper. There we go, paper. So there's that one. That's beautiful. All right, you guys do part D. Yeah.
What was part A? Did we...
Oh, did we finish this one? Part A, we sort of stopped early on part A. What's the sign of 30?
3 over... No, it's 1.
1 half. Because sine likes y, 30 is close to x. Sine don't like it, it's going to be small. Yeah. All right, so do part D. So the first part of the work we've already done, right? 330 ends up how short?
30 short.
30 degrees. So tangent of 330 is related to tangent of 30, and then you figure out the sine, SIGN. So in this quadrant, remember what's tangent built on?
Y over X.
Sine and cosine, right? And y over x, exactly. So in this quadrant, x is positive, y is negative. So when I divide them, I'm going to get a positive or negative number. Negative. I like it. So tangent will be positive when sine and cosine have the same sign, SIGN. So first quadrant, third quadrant, tangent's positive, cotangent's positive, right? Because over here it's all positive, over here the negatives cancel. These two, oh shit, one's positive, one's negative. So quadrant 2 and quadrant 4, I guess from your perspective there, anyway. You guys kind of with me? Yes.
Wait, isn't it, I don't know, isn't it the other way where the negatives cancel if it's in the third quadrant?
That's what I said, but as I'm doing it from my perspective.
Oh, yeah.
So yeah, so in the first and third quadrant, the signs are the same for sine and cosine, right? So tangent will be positive. Second and fourth, the SIGNs, the signs of sine and cosine are opposite signs, so the tangent's going to be negative there, right? You guys with me? And again, you don't have to memorize that fact. You can just memorize where sine and cosine. Sine and cosine are y and x. So tangent, sine over cosine, you can figure out what sine is going to be. You don't have to memorize that. Does that make sense? Do you see what I'm saying? I don't want to memorize a bunch of shit because I only have so much room in my head. Yeah.
So the sine SIGN for cotangent, if tangent is negative in the second and fourth quadrant, it would be the same.
Same thing for cotangent because cotangent is just reciprocal. Yeah. So if tangent's positive, cotangent's positive. If tangent's negative, cotangent's negative. Yeah. I like it. Okay. So, how do you get tangent of 30 if you don't have it memorized? And that's an option. You can memorize the tangent stuff too if you want to. But isn't that sine 30 over cosine 30? Oops, sorry. You guys tell me if I'm not on there. I don't like the overhead. What is sine of 30? Yeah, because sine likes y, and this is closer to the x-axis. What's cosine of 30? What do the over 2's do?
Cancel.
So then I get,
-1 over rad 3.
and then rationalize, yeah? Rad 3, negative rad 3 over 3. Now what I do have memorized is tangent is big when sine is big, tangent small when sine is small. So tangent could either be rad 3 or rad 3 over 3 for 30 and 60. Sine's small at 30, so tangent's the smaller option at 30 degrees. Right? So, but it's up to you how much you want to memorize or not. Yeah.
Isn't that 1/2?
What's that? What is it? Sorry?
Would it be 1/2? Rad 3 over
1/2? Why?
Not exactly.
These two canceled, right?
3? Yeah, but 3 is simplified down to 1/2.
Oh, this piece?
Yeah.
How would you do that?
Well, because the rad 3 is just half of 3.
It's half the 3 multiplicatively. Yeah. So, sure, if I had half of 3 additively, now I know that says multiplication, right?
Yeah.
But 2x, what does a 2 mean in 2x?
2 times X.
Plus X.
It's x plus x. So that is, so coefficients are additive. They tell me how many of this do you want to add to itself. Exponents are multiplicative, meaning square root of 3 is 3 to the 1/2 power, right? It's not half of 3. So yeah, if I had half of 3 divided by 3, that would be 1/2 all day. But that's not what this is. Yeah, okay. Is that all right, guys? So we got negative rad 3 over 3. Number 3 at this point, should be relatively easy. If I were a student in this class, you should be kind of happy if you see me give you a problem like this. And we'll find out. It's just like number 1 on the quiz, right? On the quiz, what was it? Wasn't it a triangle and stuff? Yeah. So hopefully that's true. We'll find out. One nice thing about this first triangle, it might be upside down, but is the angle in the base. Yes. So this is the what side? X. And this will be the y side, and this is the hypotenuse. Now the difference with this problem is, do I have enough sides to make ratios? No. And do I want the trig values here? I want to know all the angles. Okay, that first part's going to be easy. What's the only angle we don't know?
47.
Yeah, the one down here, right? And what's this one going to be?
47.
47. Kick ass. Is that cool?
How is it 47?
That's 43. That's 90. And altogether, any triangle. Yes. As long as you're in Euclidean geometry. Sorry. Which we will always be. So it will always be 180. But there are triangles. That's not true. But no, don't worry about it. Sorry. That's some freaky shit. All right. So ready with me. So our triangles will always add up to 180 degrees inside. Okay. So that part's easy. I only know one side. So would Pythagorean theorem help me?
No.
Because I'd have too many unknowns, right? But what trig function relates the angle I'm given, the side I know, and some other side? There's 2 options here.
Cosine 43 or secant.
Yeah, if I do cosine of 43 degrees, and now you see why I labeled these for myself. What's cosine?
X over R.
So it'll be what over what?
24 over R.
24 over r. Now, if you gave me back the calculator, you might want to get it again. Because is 43 degrees an angle you're supposed to memorize anything about?
No.
Thank the gods. So you got to use your calculators. Calculators. Do you know how to solve that damn thing for r, though?
Yeah.
How do I solve that for r? Yes. No, because that would be multiplying both sides by 24, which does not cancel the 24. Does it make sense? The worst thing about this problem, the variable I want is on the bottom. So how do I get it this shit up? Multiply by R.
Divide by cosine.
Yeah, we'll get there. If I multiply by r, my variable is up, yes? If I'm trying to solve for a letter, I do not want it on the bottom of something. Do you guys agree? That sucks. How do I make r equal something when it's on the bottom? So first thing I want to do, multiply the r up. So let's just do that. Times r times r. This still sucks. A little bit. I still only have a statement saying r equals. So of course, what do I do now? Trying to get r by itself, so just divide by. So you got r equals 24 divided by the cosine of 43 degrees. Can you guys all please don't say anything, just put that in your calculator. Yeah?
Maybe round 2.
Oh, I normally say 2 places. To the hundreds place, right? Hundredths. By the way, this is going to happen often enough that I'll show you something kind of nifty as soon as you guys get this. Is everybody able to do this? What did you guys get?
32.82.
32.82.
82.
And normally in a problem, I'll give you some units. There's no units on this sucker, so you can just be unitless. But be really careful. You got to put the units in if I give you units. If I don't, it's beautiful. It's just numbers. Who cares? Why does this make sense so far? What about this makes sense?
It's bigger than.
Yeah, it's bigger. R should be the biggest side. It's bigger than 24. Makes sense. If you get 11, that should immediate red flag. Don't just circle that shit and go, yay. No, it should immediately go, no, that doesn't make any sense. Are you guys with me? Do you have to always do that? No. But that's a quick check just to make sure you're on the right track. Yeah.
In this situation, would y be negative?
Oh, I see what you mean. No, this is a physical triangle. I just wanted to flip it just to make sure you knew how to figure out what's x, what's y.
Okay.
This is a physical triangle. Yes. Okay. It's not living on the xy plane. Does that make sense? I'll make it really clear if that's the kind of problem I want. Okay. Okay, so now we have this side length. Now we have two options. How do we get the last side length?
Tangent.
Yeah, I could either do tangent or I could do Pythagorean theorem because now I have two sides.
Be less accurate.
I would accept either one. But why would doing Pythagorean be less accurate right now?
Because if you square it, it would be still be a decimal.
Is 32.82 the exact right answer
No, it's
here?
rounded.
No, it's rounded, right? But again, if you do Pythagorean theorem to get the last side, I'll take it. Because that's the right kind of idea. But it's not going to be really accurate because we rounded this number, right? So let's see if we can do this. Oh man, I've got no time ever, Jeff. Let's do Pythagorean theorem first. How would I set up Pythagorean theorem?
Y squared plus 24 squared.
Yeah, so these two sides have to add up to be the biggest side. So I'll get 24 squared plus y squared equals 32.82 squared. Right, so I get y squared equals this mess minus this mess. Who's got that for me? You guys have calculators. Calculators. What is it? Sorry? 501 point stuff. Here, let me actually show you something. All right. So if I do
You got 24 points.
32.82 squared minus, where'd it go? 24 squared. Yeah, so I get this, right? Now this is not that bad because there's not a lot of decimals. But if I hit, now what do I want to do that? Is that y?
No, that's
Y squared. So I want to take the square root, and I can always hit A and S down here. That's the last number that showed up on the screen. Bam. Especially when there's like a billion decimal places, I don't want to have to copy it all. I can just hit that button, and it knows I mean the last number that showed up. That's the immediate memory spot on the calculator. So then we get y equals 22.39.
Yeah.
I'll get there eventually. All right, so see what we get real quick. If I instead did the tangent, the tangent of 43 degrees would be what?
Y over 24.
Yeah, it'd be y over 24. Now this one's nice. How do I solve for y?
Y equals 24 tangent.
Yeah, I multiply by 24. Everybody make sure that's right. Oh, that's weird. Oh, what happened to you? Okay, there we go. Boom. I had it in radians, poor little dude. So I get 22.38. How does that relate to what we just got? Oh, that's pretty close. All right, we got lucky. We got really lucky, okay. But very easily, it's called error propagation. If you have a number that's not quite right and you do math to it, it's going to get further and further and further away from the right answer. The error kind of like grows as you do stuff to it. I don't know if this makes any sense. I would accept either one though. Oh man. Real quick. Skipping this problem for a minute because it'd be the exact same. You just gotta be careful about what's x, what's y. Look at this problem. We did one sort of like this together, I think. So we draw this tree, Hyperion. It's about 379 feet tall. How far away from the base of the tree must I go? And here's this. I don't remember if I said this. Angle of elevation would be, if I look straight out, the angle I have to move my gaze through to see something is the angle of elevation. If I was in a plane and I saw somebody down on the runway, that would be the angle of depression. So if I have to go down from looking straight out, that's angle of depression. If I have to go up from looking straight out, that's angle of elevation. So if we look at the top of the building, elevation. If I'm on the top of the building, I'll look down at somebody else, angle of depression. Are you guys with me?
I guess I call it angle of depression.
I know. Poor little problem needs some help. Okay. So I want the angle of elevation to be 11 degrees, right? So the question is, how far do I have to walk before that happens?
Just take tangent.
Yeah, so whenever you do this, draw the picture and you say, okay, what trig function relates what I want to know with what I know? I don't give a crap about this side, right? So I don't want to use anything that involves r. So I can use tangent in this case. What's tangent of 11 degrees? What over what for tangent?
Oh, it's 379.
Yeah, y over x. It'll be 379 over x. And then you can solve that like we did earlier. I'm basically out of time, so shoot. We got through, to be honest, this basically is section 2.4 for the most part. We're going to do some more examples. There's a problem, like I talked about, with finding the width of a lake. There's a problem like that in the homework section. Yeah, so next time we'll just finish up 2.4, we'll get into 2.5. I'll have the quizzes graded. Cool. Don't forget your ID and phone, please, dear God.
Do you turn these in or
What's up?
do we keep these or something?
Oh, the worksheet?
Yeah.
That's yours. Yeah.
Uh,